Hey, Vlad here, devinsider.com. Welcome to another video. In the previous video, we have seen how to build internal DSLs with or without implicits. Today, we will use bits and pieces of that knowledge, but learn something else entirely. We will see how maps can implement joins, traditionally known from SQL databases. I'm super excited about this. Let's get started. Alright, so the way I prefer to make my videos is to pretend as if you, the viewer, have only the knowledge that I have presented in my videos before. So I'm trying to sequence my videos, so to say. I know that it's a little bit far-fetched from the truth, but some of you might have discovered my channel even before starting programming, and I don't want to let you down. Aww. So here's the shortest crash course in the history of crash courses about databases. And if you already know what databases are, feel free to skip this tiny part. A database is a program written in some programming language, and it can do pretty much only two things. One is it can write sets of data to disk, and writing to disk means that the data will still be there even once you turn the program off. And the second one is the ability to find subsets of that data. So when you write your program, it talks to the database program over the internet or of the local network, or maybe the database program and your program run on your machine at the same time, and they talk to each other with a thing called inter-process communication. But there is no need to worry about that. Today we're going to pretend as if we have a database, and we're just going to have regular function calls inside of our application. So we're not going to have like two applications talking to each other or anything like that. The dialogue between your program and the database program consists only of two things. You can either ask the database to write some data to disk, or you can ask it to read some data from disk and send it back to you by sending it the read query. We will not dive into the writing part too much, but traditionally the databases stored their data in tables, and a table would be called something like a person, and the columns would be the attributes of a person, for example the person's name or the person's birthday, and then every row would be an instance of a person. The read queries that you would send to the database would use an external DSL called SQL, which stands for Structured Query Language, and is sometimes falsely pronounced as SQL. A query would look something along the lines of, go get these columns from this table for the rows that have a birthday which is before the year 2000. And it is very, very vital for this video to understand that the results are themselves tables. Rather sooner than later, you will end up in a situation where you will have multiple tables. For instance, you will have a table for people and you will have a table for cars. And both of these tables will have a column called ID, which was just a number generated by the database. You can think about it as an always growing number. And the cars table will have a separate column with the ID of the owner, which is the ID of the person. So when you send a read query to the database to read data from multiple tables, what you will have to do first is join those tables together, so to say in a virtual table, and only query that virtual table so that the result that you will get back will also be a table. And this is where maps come in. As I told you, it was the shortest crash course in the history of crash courses for databases. If it was too fast for you, don't worry, we're going to take it super slow from now on. As always, we're in the Ubuntu virtual machine, and we have Sublime Text Maximized with a plugin called Terminus, which emulates the entire terminal for us, which runs SBT, which reruns the test every time we save the file. So the first thing that we're going to do today is we're going to create an entirely new suite. We're going to call it map join suite.scala, and we're going to switch right away to running only that suite once we create it. Actually, let me go to map suite real quick. Let me go up. Let me copy that. Let's actually have way more space over on the left side. Let's have it over here. Map join suite, like that. In fact, we can right away also import map join suite, which is going to be a companion object defined over here, MJS, right? Like that. Okay, so let's have a test. Hello world, and say 1 should be 1, and let's switch to running only that suite. All right, so I'm going to have test only user.map join suite, and there we go. We have only our hello world test. All right, so what I prepared for you are fancy looking Ascii tables. So what I'm going to do is I'm just going to paste them in over here. So we're going to have a comment that starts over here, ends over here, and we're just going to go over here and paste them. Okay, so these are our tables in the database, and we're going to pretend that something went wrong. I don't know, maybe some bug. And what happened was that this row is missing. All right. By the way, I also got tired of Alice and Bob, so we're going to switch to the NATO alphabet. So we have Alpha, Bravo, Charlie, and Delta. All right. And from this table, this one is missing. Okay. So the Dodge is missing, right? Like that. And it also doesn't have an owner. There we go. Okay, I'm gonna save the file, but there's actually no point because we didn't actually add any code. Now let's say that we don't want to let the database join the tables for us. Let's just ask it to give us both of these tables back, like all the data in those tables, and we're gonna join them ourselves in memory. This happens actually quite often with no SQL databases that don't structure their data in tables, right? So you get them out and then you join them manually, and we're gonna then get some data out of them and structure them as maps. But the table, you know, if we were actually doing the joins in the database, then the table that comes back would look something like this. So we're gonna join them obviously on the person ID. So we're going to have the person.name. We're going to have the car.brand. For instance, we didn't get the car ID because we simply don't need it. So this is sort of like this virtual table that is that we're looking, and we're sending queries to this table. So let's encode that as maps. So we're going to stay in the companion object, and we're going to have a few type aliases that will help us out, just to help readability. Remember the type aliases like this, they don't actually enforce type safety in no way. It's just for readability, right? For you guys to understand it better. So we're gonna have a type car brand equals string. Okay. So now we're gonna have people, which is a map of person ID and person name, and it's a map of basically just reading data from the table, right? So one is going to be alpha, and two is going to be missing. Right, so we're going to have 2 is missing, and we're going to have 3 is, let's see, 3 is Charlie, and 4 is Delta. There we go. So these are the people. Let's save the file. Let's see what Calariform is going to do. Okay, nothing. That's cool. All right, so we're going to have cars, map of person ID, car brand, like this, equals map. 1 is, let's see what we have. 1 is an Audi, and 2 is a BMW, and come on, and 3 is a Cadillac, and 4 is missing. 4 is missing. There we go. Let's see what Calariform is going to do. Now, there are different kinds of joins, and the first one that we're going to implement is going to be the most straightforward, the most obvious one. It's called the inner join. So it will only give you the data that is complete. So if we look at the over here, so it's not going to give you this row, and it's not going to give you this row. So let's start by writing a test for it. So we're going to go over here, and we're going to just going to call the test inner join like this, and we're going to take the people table, which comes from this import, right, from the companion object, and we're just going to call inner join that we don't have yet. We're going to give it the cars, and what should come back is a map with only the valid rows, right? So what comes back is a tuple of alpha and Audi. And by the way, I'm going to use the alternating syntax for tuples, right? So this is one syntax to create a tuple, and this is another one. Right, I'm going to use it just for readability purposes. Like usually I would stick to only one. So we're going to have Charlie, and we're going to have a Cadillac. All right, it's not going to be a 2, it's going to be a 3 actually. All right, so 1 Alpha Audi, 3 Charlie Cadillac. If you look at our tables, 1 Alpha Audi, 3 Charlie Cadillac. The other ones, they're corrupted in one way or the other. All right, so it rightfully complains that we don't have this method. So let me copy that. Let's go to maps somewhere at the bottom. Actually, you know what? We're actually going to start writing them as a DSL. So what we're going to have is we're going to import over here map join, right? And map join is going to reside in the it's actually not going to reside anywhere. We're going to create another file called mapjoin.scala, right? It's going to be package homegrown dot collections, right? We're going to have an object map join, and over there we're going to have a DSL, as we learned in the previous video how to create them. DSL, it's going to create a key, and usually I say key value, but in this case I'm going to say key this value because we're going to have two maps, and there's going to be this value and that value, and it's going to be simpler to understand. So we're going to have a private vol self, which is a map of key, and this value, it's only private because there's no need to expose it. Okay, and we're going to have def, and I'm going to paste it inner join. Right, so inner join, it has that value. Okay, so what it gets is a that map, which is a map of the same key, very important, it's the same key, but the value is different, right? So what comes back always is going to be the map, you know, with the same keys, you know, 1 and 3, right? Keys were integers in people, in cars, and in the map that is being resulted, but the value is going to be different, right? So it used to be strings, but now it's going to be a tuple, right? So we're going to go over here and we're going to say, okay, so it's going to be map of key and a tuple of this value and that value. And by that time, we actually need way more space here, so we have better readability. Okay, so I'm just going to do that just so that it compiles. All right, so now let's add the implementation. So we're going to start by traversing this map. Okay, so we're going to go, we could just start doing self.fold. Okay, and the result is going to be a map of key and tuple of this value and that value, like this. Okay, and we're obviously going to start with an empty map, right? So for example, if all the rows are corrupted or if both tables are empty, then it's going to be an empty map. Okay, so usually we have something like this over here. We usually have ACC and current, right? But our current is a key value pairs, right? So instead we're going to use a partial function over here. We're going to say case, and instead of current, we're going to say, whoops, instead of current, we're going to say this key and this value, right? Because we're traversing, you know, this map, right? So self key, self value, basically. And we're going to have it over here. We're going to have it like that. We're going to have an arrow to the right. Okay, so we're traversing this map. We have this key and this value. So the first thing that we're going to do is we're going to retrieve the value for this key from that map. So we're going to have this key, which gives us an option, right? So we're going to map on that option. Oops, like this, map. Okay, so if the value is there, that value, okay, then we're going to do something. And otherwise, we're just going to leave the map alone, right? So as soon as one of them is corrupted, then we're going to leave the, we're going to leave everything alone. So scc.add, right? So this is the case where we found the match, right? So in the map that we're constructing, in this new map was the key and the tuple. We're going to add this tuple, this key, this value, that value, right? And this is already the entire implementation, right? So this is the inner join. We're only taking the, the fully correct rows where all the data is there. It's actually kind of simple. We're traversing this map every time for the key. We're getting that value. So we have the key, this value, and that value, and we're using all of them over here. And as soon as something is missing, we're just going to leave the accumulation alone. So we're not going to add another element. All right. So before implementing all the other joins, and in fact, it's going to be 7 of them, they're very, very similar. So it's basically going to be a bunch of copy pasting. We're going to do something a little bit different. So let's say that we didn't want the inner join method give us tuples back. Let's say we wanted to automatically convert it into something that we actually can use right away. For example, into something like a person with car brand. So we're going to go down to the companion object and we're going to create a case class over here. And we're going to call it person with car brand. Okay, it's going to have the name of the person, right? And it's going to have a car brand, which is going to be a string. Okay, save that. Okay, so let's say that we had a factory. We had a factory of how to produce a person, a factory of basically give it 2 strings, the name and the car brand, and it will produce you a person with car brand. And it turns out that the case objects, they generate this apply function, and the companion object of a case class extends exactly this function, right? So this code will compile. We're actually not going to use this. I just wanted to show you this. So I'm going to comment this out for a bit. Okay. So what I want to be able to do is I want to be able to say, okay, people dot inner join cars, right? And I want to be able to pass this factory, or right away, person with car brand, and it should be exactly the same map like that one over here, right? But not as tuples, instead as person with car brand, right? Because tuples are essentially data structures without a name. Well, they sort of do have a name, but you know what I mean. Okay, so the first thing that we need to do is we need to add a factory as another parameter, right? So we're not only passing that, we're also passing a factory, which takes a tuple of, not a tuple, which takes two parameters, this value and that value, okay? And it produces a target value, and the target value is going to be yet another parameter over here, target value. And now instead of giving tuples back over here and over here, right, we're just going to say target value. And now what we need to do is we need just to call factor over here, pass in this and that, and it will create that. As of right now, it probably shouldn't compile. Yeah, it shouldn't compile because we fixed this one, but now we broke this one, right? So this one is the one that is not working right now. So what we need to do is we need to say that the factory by default should just construct a tuple, right? So we have a factory over there. In fact, maybe let's press enter like this and press enter like that, and just hope that Scalariform is not going to kill it again. Let's do it like that. Let me actually save it and see if Scalariform ruins it. No, it's all good. Okay, so what we want to say is that by default, it should just use tuple2, and it's the same code as we used as over here, the factory for person with car brand is person with car brand, so the factory for tuple2 is going to be tuple2. The only difference is that tuple2 is actually parameterized, so it's not going to work just like that. So what we can do is we can do .apply. It's not going to help. What we can do is we need to explicitly tell it to convert this method into a function, and then the type inference is actually going to kick in, and we're going to improve that in just a bit. So let's go and uncomment this code, and let's see what happens. Oh, it still doesn't happen because it doesn't know the types, as I said, because they are parameterized. Okay, so well, let's add them over here. Let's add string, and let's say tuple2 string. Okay, this is the type, right? Let's see. Oh my God, it still doesn't work. And every time you see nothing, this is where you need to understand that type inference did not do its job properly. So what we need to do now is we need actually to go to the apply function over here, and we need to help it out to say this value and that value. And I believe that this should work now. It works now, but it still kind of looks ugly. So now we're forced to use these parameters. So if we comment them out, then it actually still doesn't work. Now I'm going to show you a magic trick that that solves that, and this is like one of those things that you sort of learn with a bunch of experience in Scala. And this trick goes by the name of current functions. So if we have, instead of a comma here, we're going to close this parameter list. I'm going to start a new parameter list like this. Let's see what's going to happen. First of all, it's not going to compile because we're calling it wrongly. Let's call it like that. So this is going to be the first parameter list. This is going to be the second one. And over here, the second parameter list is going to be nothing, right? It's going to be an empty parameter list. And now all of a sudden it works. So now all of a sudden we don't need this. We don't need this tuple. I'm sorry, we don't need this type. And actually, let me also remove this comment, right? So if you want a tuple, we do it like this. This still looks kind of ugly. And if you want a case class, we pass it an explicit factory. Just as an extra explanation, what happened here is that the type inference, by the time it inferred the types in the first parameter list, it already had more information to infer the types in the second parameter list. And so it did. So the only thing that is left to do is to remove this ugliness. So we're just going to have at the very, very bottom over here, even under the class, we're just going to have a private def, a tiny private def that will help us out. So we're going to have a private def, and we're going to call it T2, and it's going to get two parameters, first and second, and it produces a first and second to tuple2. So it's a higher order function, right? So it's a method. When you call it with two parameters, it will produce you a function that will take two parameters and produce you a tuple with first and second. Tuple2 with first and second. In fact, we could actually do this. But now it's kind of confusing, right? Because this is actually a tuple, so this is sort of like that actually, right? So instead, I'm going to go back to saying tuple2 first and second, like that, and all it will do tuple2 dot apply. And what we can do now is we can spell things correctly, tuple2 dot apply, and now over here, come on, tuple2, there we go. And now over here, instead of tuple2 dot apply, we can just say T2, and we still need, I believe we still need this value and that value. Hold up. Oh yeah, we don't. That's cool. We can just say T2. One last thing to do here is to get rid of those pesky parens over there. And there are two ways. One way would be to use function overloading. One will take the factory as a parameter and the other one will not. The problem is that we have a curried function. So if you try to overload inner join, let's try to overload it actually. So I'm going to have this, and I'm just going to say that it returns a map of key, this value, that value, and we're just going to throw an exception like that. Okay, this shouldn't work because it says that, hold up, let me go up here a little bit like this. It says both method inner join and class DSL of type so-and-so and method inner join and class DSL of type so-and-so match argument types, right? So because the first parameter looks the same, remember that, function currying is just a, like this multi-parameter list thing is just it's just a syntax for function currying. So in fact, this is just a function, this is just a method that returns a function, and therefore we can't use function overloading. What we can do is we can use implicits, and I know I promised you a full-blown video about implicits, and it will come actually very, very soon. Please be patient. But what I told you already is that implicits can occur in two positions. One is when the compiler wants a type A, but you give it a type B, and you just happen to have an implicit conversion in scope that converts A to a B. And the other one is you have an A, and you call a function, a method on it that is not on A, but it is on B, and you have an implicit conversion somewhere in scope which converts an A to a B. Then the compiler will find it. And there is a third place for implicit, which is called, it's not called implicit conversions, it's called implicit parameters. And it can occur over here, right? So you can say that the entire parameter list is now implicit. So when the compiler will see that you don't have, that you're not providing this parameter list, then it will try to look, in this case, for exactly this type floating around in scope and inject it. Now, the use case for this is actually completely different, and what we're going to use it for is actually a bit frowned upon, and we're actually going to get rid of it by the end of the video. But at least now, we can actually go over there to this parameter list, and we can just say that it is gone. Now it's going to compile. Now it should compile. It doesn't. What's up? Nothing. Oh yeah, so now it actually has a problem inferring those types. So now we actually have to go back to T2 and have to say this value and that value. Like this. That should solve it, I believe. The only question remains is we actually didn't have an implicit with that type floating around. We didn't have it. What happened? And what happened was that we actually have a default parameter. Now usually mixing default parameters with implicit parameters is bad practice, but as I said, we're actually going to remove it by the end of the video anyway, so it doesn't really matter for now. Let's just continue. Let's leave this hackery for a bit and go back to joins. And I actually want to show you, like before we implement the other joins, that you can actually keep calling inner join and sort of say like keep nesting them. So let's say that we had colors, I don't know, colors of the cars, for example. So we would have a map of, and we're going to say, okay, 1 is missing and 2 is missing. Just so that the result is going to be shorter, and we're going to have 3 is going to be blue, right? So the Cadillac is going to be blue. And also the 4 is missing. 4 is missing, okay? Missing, come on, okay? So what we can do now is the same as we did above. We can do people.inner join cars, but then we can call inner join again, like this, inner join again with colors. And what should come back now, it should be a map with, and remember, only the rows where everything matches will be kept. So there's only one, was a 3. Right, so there's a 3, and now the value is itself a tuple, and the key for the tuple, I mean the first parameter for the tuple is going to be basically that. It's going to be Charlie and Cadillac. There we go. This one, and it will be again a tuple of blue, right? So we're not, the tuples are not flattened, right? We would have to do something very special in our DSL to flatten them, which we're not going to do today. I just wanted to show you that, that this DSL is already a little bit flexible, so you can keep joining things. So if you have 3 tables instead of just 2, which is very common for databases, you can join over multiple tables. All right, so the time has come to write the test for the next join, and this is going to be the left outer join. Left outer join, and it's going to look like this. So we're going to have people, we had inner join, but now we're going to have left outer join, and we're going to have cars, and I don't know why I can't spell all of a sudden. Okay, join cars, and this should be, and I'm going to go to the inner join, and I'm going to copy that. So what left outer join is doing exactly the same thing as the inner join, but it also gives you additionally the values, the rows that are present in the first table, so in the people table, but that are not present in the second one, right? So delta, and now this value is not present. Now, what are we going to do here? We still need to provide a string, and we could use null. This is the same, the thing that you would do typically in Java, but in Scala, and especially on this channel, null is a no-go. So instead, we're going to use a none, right? So we're going to use options, and therefore, we're going to have to wrap this Cadillac into sum, and we have to wrap this Audi as well into sum, like that. Now, this function doesn't exist, obviously, right? So what we're going to do is we're going to go and implement it, and implementing it is actually super easy. All we need to do is we need to copy the entire inner join like that, okay, and paste it over here like that. All we need to do is we need to call it left outer, and we need to say that what it produces is not a map of key and that value. Well, actually, sorry, it does produce the map of key and that value, but it needs a factory that understands that that value might not be there. So this is going to be an option, and over here is going to be an option as well, right? So all we need to do is over here, the target value is going to be now this value and option of that value. And therefore, if we find the value, then we just need to wrap it into a sum, right? And otherwise, we need to do exactly the same thing over here, right? And just wrap it into none. Right? So this case is where we have the value, and this case is where we don't have the value. I called it left outer. It was supposed to be left outer join, like this, right? So now our test is green, and if you're paying attention, then this entire code, this entire fold over here, could actually be replaced with this one line, which is this key, right? This one over here. So I'm just gonna comment this out, and you're gonna look at it a little bit, and you're gonna internalize how it is actually working. I forgot to comment out one curly brace, this one. Okay, right? So this is basically the only difference. If the value is present in that map, then you're gonna insert it. Otherwise, you're gonna insert none. So basically, whatever is coming back from this, that this already gives you the option, right? So basically, what you end up doing is, and if you look over here, whatever is happening on the right side, there will always be some option, right? It's either a sum or a none. And this is exactly what this code will do. It will either insert the sum or it will insert the none. But actually, I'm going to comment this out, and I'm going to leave that one instead, because it's going to help us with, with adding the other ones. Now, as I already said, we're going to have 7 joins, and this one is called inner join, the next one is called left outer join, and so on and so on and so on. And I don't like the fact that we repeat the word join. Now, we're still going to end up repeating with what about to come next, but it's going to look a bit different. So what I want to have is I want to say people.join, and then I just want to specify how. So it's going to be join cars, and then it's going to be dot inner, and this is the one that's going to have that. Okay, so the same thing over here. It's going to be join dot inner. Come on, join dot inner. Same thing over here. Join dot left outer, which is why I call it like this, because I knew that it's coming. Okay, so first of all, let me call it inner and left outer. All right, So the way we do it is by introducing a, we're going to go to the DSL over here, and we're going to say, okay, so it gets the self map, and what it will have is, instead of having all of these methods, it's going to have a method called join, right? It's going to get that value. Come on, it's going to get that value, right? And it's going to get that map, that value. Okay, and it will produce a join. Remember when we had the flight DSL in the previous video, we had a source over here. So it's the same thing. It doesn't really matter how you call it. So it produces a join with key and this value, and also that value, right? So it has all it needs. It has a key, it has this value, and it has that value, all the parameters, equals new join self that. Right, so it has all the parameters, and it has the self, and it has the that. Right, so usually they call like this and that, but we can't use this because it's a reserved word. Right, so now what we need to do is we need to let me actually collapse these two like that. There we go. So we're just going to surround them with a class. We're going to have a class join, and as I said, it will have these three parameters: key, this value, that value. Right, and it's going to get the self, which is the map of key and this value, and it's going to get, come on, it's going to get that, which is a map of key and that value, like this. And we're going to open the brace over here, and we're going to close the brace down there. Right, so basically inner and left outer are now inside, and because they're inside, they actually don't need that value. That value is already in scope. It's coming from typo from over here. It's coming from over here, so we don't need it over here, right? So we don't need that value. And in fact, we also don't need this map because it's already coming from over here. So it's basically, these are becoming functions that are not curried anymore. They only get the factory, which is collapsed now, so you don't see it. Hold up, like that, like that. No, like that and like that. Okay, so we can actually do this now. Where does it end? It ends over here. Let's just have like way more space so that it becomes clear, right? So this left outer, for example, right? It has now only one parameter list, like this. Let's actually save and see how far we got. Yeah, okay, so it actually passes. So what we can do now is, because now we don't have those weird curried functions, what we can do now is we can actually use function overloading, what we wanted actually to do from the very beginning. So now we're going to create a def inner that will just create a map right away of key and target value, but the target value is not there. The target value is a tuple of this value and that value. Right, and all it will do is it will call inner with t2 this value, that value, right? So this one just calls this one, and therefore we don't need the implicit parameter like that. Okay, actually kind of want to have it here. There we go. Okay, and we actually don't need the default parameter like that, right? So it looks like more cozy now, and it works the same way but without the implicit parameter. So I have inner, and we're going to do the same thing with left outer. So I just duplicated a line, and we don't have a target value. We don't have a factory, right? We're just producing a map of this value. Actually, this one is going to be an option of that value. Option that value. There we go. And all it's doing is it's calling left outer with t2, and the parameters are this value and option of that value. And there we go. We just need to remove the implicit, and we need to remove the default parameter over here. We don't really need it until over here, I believe, like that. Let's see. Yes, it worked. Cool. All right, so the rest of the video, we're just pretty much going to add, all the other joins that are left. And the next one is, I don't really know how it's called, actually. It's I'm going to call it left only join, because, when you write an SQL query, you don't really, it doesn't have a special keyword for that. So the way the test looks like, it's very similar to this previous one, right? To this one. So I can just copy that and I'm going to paste it over here. But the difference is that it has, because it's a left-only join, it basically negates everything that comes from the right table. So everything that is missing from the right table, it will have, but everything that is not missing, it will not have. So right, so basically this is like one of the negative cases, right? So it basically says, hey, give me only the corrupt one from the right table, from the cars. So we need to not forget to call it, so it's join, but it's not left outer, it's actually left only, which doesn't exist yet. So let's go and implement it. Okay, so we're going to go down and we're going to take the left outer, copy this entire thing, paste it over here, call it left only, right? And what it will do, it will basically just do this case, right? And in the other case, it will not do anything, right? Like this. Right, but the signature and everything else is the same, right? So it only gives you the bad case when the value is not present in that map or in that table. And some people don't like, when you have this get or else thing, because monads, and we haven't really talked about monads, but map is a monadic function, and monads are optimized for the happy path. And so the happy path usually looks good, but it looks kind of weird if in the happy path you're actually not doing anything with the value. So some people prefer to rewrite that and instead have something like this. So let's get that value, this key, all right, and instead just do if that value dot not empty, then let's just return ACC. Otherwise, basically do that thing over here, right? And we can use none over there, but we actually can also use that value. Right? So the other way would be to do, okay, let's have a none over here and have that key over here like that, right? So whatever is shorter, whatever pleases your eye, both of them work. So I'm going to stick to this one because, as I said, it's just going to make things easier to copy paste. Let me make sure to remove this one, and also remove that one. And I believe in the previous one we also left this one. Yeah, we did. All right, so the next one that we're going to have is probably going to be the right outer join. Yeah, so the right outer join is very similar to we're always going to start with the inner one, right? So we're going to go here and just do that inner join, and we're going to have the right outer join. I'm going to call it right outer, and what it will do is it will do the same thing as the left outer join did, but in reverse. So the left outer join, it even give us the bad results from the right table. This one will give us the bad results from the left table, right? So the values on the left are going to be wrapped into sum and sum, right? But we'll also have the 2, right? So this one is going to be none and BMW. Okay, so when we're going to implement it, what did I forget? I forgot I curly brace. All right, what is wrong? 56, there's no comma over here. All right, there we go. All right, is everyone happy? Yes, right outer is missing. So the same way as we did with left outer, we're going to go to inner, copy the entire thing, go down, I believe over here. No, actually over here. Right, so we're going to call it right outer, and let's create some more space, and what it will do is it needs a factory that understands that this value might be missing, and the same way over here, option, and let's see. Okay, so the left value needs to be wrapped in a sum, right, and the other one will be duplicated, and it's just going to use a none over here, right? And I'm actually not sure if we need these. What did I do wrong? Oh, obviously the most important thing. How in the hell are we going to get the values that are not present in the left map if we don't know what to associate them with from the right table? So what we have been doing all this time is we were traversing the left table. What we need to do now is we need to traverse the right table. So we're going to have that fault, and therefore this is going to be that key, and this is going to be that value, right? And now we're gonna get the value not from that, we're gonna get it from self by passing it that key, right? And we're gonna have this value over here, right? And we're gonna have that key over here, that key, factory of sum of this value, that value, and now everything should be fine if I rename this to that key. I ruined the type signatures. We actually don't need them. I can just pass T2, right? Can't I just do that? Okay, actually I messed up not this signature, I messed up on this one, right? Because this needs to be an option. But this actually shows that we actually don't need the generics over there, so we can go over here to the left only and also remove it, and also to this one right here and also remove it. Okay, and also this one. There we go. Okay, so all of them are gone and it's still working fine. All right, so the next one that we're going to do is the write only over here. Let me scroll down a little bit like that. So we're going to have test and write only join, right? So we can pretty much copy that from here, right? And we're going to call it write only, and it will only give us the bad ones, right? So only this one, the same as left only gave us only the bad ones. We're gonna do that. Okay, so let's actually copy right outer like that. There we go. It's gonna be called write only, and the only difference is that it doesn't do anything over here in this one. Right, should be fine. All right, the next one is actually super fun because this is the first time where we have not only left outer or right outer, we actually have a full outer join. So it will give us all the values, even the good ones and the bad ones, right? So from both tables. So we're going to have full outer join, right? So we're going to have, again, people join cars. It's like freaking Terminator here. Full outer. It should be map of, okay, so let's see. So it will give us 1 with, and everything will be an option here, right? So even if, you know, if both of them are sums, like sum alpha and sum Audi, please God help me to not make any spelling mistakes. And a 2 is going to be none, and sum of BMW. It basically says give me everything, right? Everything. So don't you know, don't remove anything. Sum of Charlie, and over here sum Cadillac. And the fourth one is also going to be there. Everybody's going to be there. Everything is going to be there. Delta and none. And its implementation is actually the most exciting one. So what we're going to have is we're going to probably, which one are we going to copy paste? Let's copy paste the full out, the left outer. Let's copy paste this one. Okay. Gonna go down to over here like this. Okay, so now we need to pay a lot of attention. Okay, so it's called full outer, and it has options on both sides, right? Over here, whoops. So it has options on both sides like that, and we need curly braces over here and over here, because we're actually gonna have two things here. Like this is what is being produced by the left map. So now what we need to do is we need to produce what is being produced by the right map. Now we could copy the right outer join. In fact, let's copy the right outer join. But in fact, we will realize that all we need is the left one. So we're going to copy the right outer join. Let's see. Going to paste that over here, right? And the only difference is that we're not going to start with map empty. We're actually going to start with left over here, right? And we also need to wrap both sides. So this is going to be a sum, and this is also going to be, whoops, this is also going to be a sum. And over here, I forgot, on this side is going to be a sum, and this side is also going to be a sum. Right, so the types help a lot, and it looks like I did everything right. But if you look closely, then this line is being duplicated. Just so we don't see it because of the spaces probably. ACC add. Okay, so this one says this key, this one says that key, but this is exactly the same key, right? So this part here is duplicated. like that, right? See, so basically there's no need to do that over here, right? So basically this is what I said, like this is not the right outer join, this is the right only, right? So we're taking the left outer join and the right only, put them together, and we have the full outer join. There's no need to add these items again. It just you know, it's a bit more performant like this. All right. And the last thing that we're going to do is we need to add, and I have no idea how this thing is called. I'm going to call it outer because, you know, according to me, it's the opposite of the inner join, right? So we're going to call it outer. So it's not full outer, it's just outer in a sense that it's, you know, not inner. And it's going to look like this. It's going to basically give us all the bad ones, right? So it's going to have people join cars. Outer should be map of only the bad ones. So we have this one and we have this one, you know, the ones that contain the ones that contain the none. So we just need to go and copy paste the entire left outer join, the entire full outer join, which ends somewhere, I believe, over here. I believe paste it over here. We're gonna call it just outer. And the only thing that it needs to do is it shouldn't add any good values, right? So this thing is also gone, right? I believe that's it. All right, so these are all the joins, all the 7 joins that are known to me, except for maybe the cross joins, which is not really applicable for maps. I mean, we could do it, but you know, if we do it, we might as well use sets. All right, so instead, what we're going to do is I'm going to show you how to have this entire DSL work for standard library maps as well, and you might as well, you know, create your own library and, you know, build on top of it if you really want to. So we're going to go here is we're going to create a class called standard library map join .scala, right? And what we will do is we're going to go to map join, going to copy paste the entire thing, right? But this thing is not in the package homegrown collections now, right? So we're gonna remove that, and instead we're going to import Scala collection map. So if we don't have this import, then we only have this for the immutable map. So we want to have this for all the maps, right? So the next thing that we're going to do is everywhere where we say fold, we're just going to say fold left, because this is just how it's called in the standard library. As you can see here, I selected nine matches, so I'm going to say fold left like this. And the next thing that we're going to do is everywhere we say this key. In the standard library, what we get is the value right away. In our homegrown collections, we're getting an option, but there's a way to retrieve the option from the standard library map. So I marked all of them. We have 5 matches. So instead, we're going to have that dot get this key, and the same thing we're going to do for self that key, right? So I'm just going to mark all of them. I'm going to say self.get that key, and the last thing that we need to do, I believe it's the last thing, is .add is called plus in Scala. All right, so it's just dot and the plus symbol like this. And unless I've forgotten something, this should actually be it. So this should compile. Yes, it compiles. So what we're going to do now is we're just going to create a tiny main method that highlights how this works. So we're just going to go down, create an object, standard library map join app extends app, and it imports standard library map join, which I actually forgot to rename. Let's actually go up and do that. Let me go down now. Okay, so what we're going to have here is I'm going to copy paste the code from the companion object from here. So we're going to have that. Just gonna paste them over here. So now these are the maps from the standard library. Okay, so all we need to do now is we need to scroll down. In fact, let me actually I just jump somewhere else so that I can copy my favorite hyphens, right? So we're gonna have 2 of them. Let's actually switch to running that main, run main standard library map join. We have my hyphens. Great. Okay, so let's print out people dot join cars, and let's do the full outer join, full outer. Okay, there we go. It looks kind of not cool. Let's do that instead. Let's do a 25 over here, and let's do that. And the standard library has a function called make string which has these. In fact, let's just remove this one. Okay. So yeah, it works for the standard library. You might as well publish your own library that builds on top of that. If you do that, please try to figure out a way for when you join multiple times that you get a flattened tuple instead of nested tuples. And yeah, so all we need to do now is commit it. So let's commit it like that. Add everything, commit -am video 24 SQL joins. That's how I'm going to call it. All right, git push. There we go. So let's go over here. Let's refresh. And we have the video 24. Come on, SQL join. Should have called SQL joins, but whatever. All right, so what's happening to my internet? All right, so we added the map join. We added the standard library map join. We added a map join suite with those beautiful tables that GitHub only partially knows how to render. And yeah, that's pretty much all that I have for you today. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and most importantly, take care.